Hello everyone, today we have Pre-Calc lesson 48. We're going to talk about powers of trig functions and perpendicular bisectors. So trig functions, when they have a power, let's look at sine, we don't write it like this. Sine squared theta is not written like this, okay? Instead, we write it like this, sine squared of theta. Okay, this is the notation you will see pretty much always, okay? Now, what it means though, it means this. You take the sine of that theta and you square it. So, let's do an example. Okay, we're going to do the sine cubed of negative 60. Okay, so, as always, we draw our graph. We have 60 degrees here, 30. So, root 3, 1, and 2. So, negative 60 is here, and we know that the sine of 60 is opposite over adjacent, so root 3 over 2. All students take calculus. It is negative because we're in the fourth quadrant. So what we have here is we'll have negative root 3 over 2 cubed. Okay, and then you just cube it like you normally would. Okay, so when we do this, we get negative 3 root 3 over 8. Okay. It's as simple as that. Let's do a couple more. We're going to have the cotangent squared of 330. So 330 again puts us over here. So we have 30, 60, 90. So the cotangent of 330 is 1 over the tangent of 30. Which we know the tangent of 30 is opposite over adjacent, so we have 1 over root 3, which gives us root 3, and it is negative because we're in the fourth quadrant. So now what we get here is we get negative root 3 squared, which gives me positive 3. Okay, let's do another example. If we had the cosecant squared of negative 405 minus the tangent squared of 45. Well, tangent squared of 45, we know in our 45, 45, 90 triangle, the tangent of 45 is 1. Okay, that's kind of the easy portion. Now let's look at the cosecant of negative 405. Okay, so if we have 405 minus 360, negative 405 will go all the way 360, and then we'll go 45 past. So again, I'll have 1, 1, root 2, so it'll be 45. So the cosecant of negative 405 is the same thing as the cosecant of 45, which is 1 over the sine of 45, which we know the sine of 45 is 1 over root 2, so we have 1 over 1 over root 2, which is root 2. Okay, and all students take calculus. It's negative because we're in the fourth quadrant. So now we have the cosecant squared, so we'll have negative root 2 squared minus 1 squared, which root 2 squared gives me 2, so 2 minus 1 gives me 1. Okay? All right, now let's talk about perpendicular bisectors. Okay, a perpendicular bisector what we will be given is basically we'll have that method we use to find the line equidistant from 2 points. We will be given points, and these are the endpoints of a segment. Okay, what we are doing is we're finding the perpendicular bisector to this segment. So we first find the slope. Find the slope between these 2 points. Then we find the perpendicular slope. Then we have 2 methods we can use. Okay, one method is we can use the locus definition method. which is what we did before of finding the distance between 2 points, okay, using the distance formula, or we can use the midpoint formula and find the midpoint between the 2 endpoints they give us and use that to find the equation of our line. I think the midpoint portion is a little bit easier. It's also what your book does. So that's what we're going to look at. So let's look at this example. We want to find the equation of the perpendicular bisector to the segment whose endpoints are 4, 2, and 8, -3. Okay, so I'm going to graph this to kind of give you guys a picture. 4, 2, 8, -3. So we have this segment here, okay? I can draw a right triangle based off of that segment. And then if I estimate a point halfway through, we are going to get the perpendicular line here. Okay, that's what we're doing. You don't have to draw the graph every time. You don't need it. I just wanted to show you. Okay, the first thing we're going to do is we're going to find the slope between these two lines. So the slope we know is the change in y over the change in x. So we will have -5 over 4. Now I want the perpendicular slope to this, which I know we do the negative reciprocal. So my slope will be 4 over 5. Okay, so far my perpendicular bisector looks like this. Now I need to find the midpoint between these 2 points. The midpoint, I have the average of x, so 4 plus 8 over 2, and the average of y. Okay, so this gives me the points, right? If I have 4 plus 8 gives me 12 over 2 is 6, and 2 minus 3 gives me over 2 gives me 1/2. I'm going to use this point in here to solve for the full equation of my line. So I'll get 1/2 equals 4 over 5 times 6 plus b. So if I wanted everything to have the same denominator, I'd make it have the same denominator of 10. So this would become -5/10 equals 48 over 10 plus b. b is -5.3. You can solve for b however you want. That's just one way. So the equation of my perpendicular bisector is y equals 4 over 5x minus 5.3. Okay, that's all. All right, let's do another example. We want to find the equation of the perpendicular bisector of the line segment whose endpoints are 4, -3, and -2, -5. And we want to write in general form. Okay, so we first find the slope between these two, which is the change in y over the change in x. So this gives me -2 over -6, which I know is 1 over 3. Okay, so I have to find my perpendicular slope, which will be -3. Then I need to find my midpoint. It's going to be the average of x and the average of y. So this gives me 1 and -4. So my equation, I'll have y equals -3x plus b. I'm going to use this point to solve for b. So -4 equals -3 times 1 plus b. So I add 3, so I get b is -1. So in slope-intercept form, I'll have y is -3x minus 1. This is slope-intercept. Okay, we should remember that. Now I want to get it in general form, so I'm going to get everything on the same side. So I'll have 3x plus y plus 1 equals 0. That is the general form of that line. Okay. These are kind of problems that start to relate all the things that we've been doing so far. right? Using our midpoint, using our perpendicular slopes, being able to know the different forms of the equation of a line. Okay, make sure you know how to do all those things, and make sure you know all the different forms of the equation of a line, because we will be using them over and over and over. All right, that is all for now. We'll see you later.